I'm Tom, and this is part 2 of my firmware basics video. Basically, in part 1 I talked about all the features and configuration options in Marlin that you needed to get your printer running for the very first time and to get the basic functionality going. In this part I'm going to show you some of the more advanced features and options in Marlin that I found useful over the last couple of years and that helped me get my printer doing exactly what I wanted it to. They are options that you might not immediately use. They will come in handy as you start digging deeper into 3D printing, the features that Marlin gives you, and as you start tweaking your 3D printer to your liking. So if you haven't seen part 1 yet, you can watch that right here. Lots of the information I give you in this video builds on the information in that one. So if you haven't seen that yet, you should go pause this video, go over there, watch it, and then come back to this one. So let's get to it. So first things first, as you already know, you can open up the Marlin firmware by double-clicking the marlin.ini file, and that will open it up in the Arduino IDE. Thing is though, the Arduino IDE is quite limiting when you're digging deeper into the advanced stuff. For example, I will be showing you pins.h and thermistortables.h, and when I use the drop-down menu to select those files, I can see the pins.h file here outside of the recording area of my screen capture, but for example the thermistortables files isn't even visible. You can switch through files by using the Control, Alt, and left and right keys on your keyboard, but that is a good bit too tedious to use. So instead I'm going to show you all these files in an external editor, and I'm going to be using Notepad++ for that, which really is an awesome editor. It gives you nice formatting, the option of closing down certain sections, and some auto completion. So really, if you don't know about Notepad++ yet, you should definitely check it out. It's free. It's open source even, I think, and it's a really basic but really good editor. So the first file I want to show you is marlin main.cpp. That's like the main file of the entire firmware. And what's interesting about this file is that it has a list of all the G-code that your version of Marlin supports. So starting with the G1 or G0 commands for simple moves over the G28 home and G29 auto probe command, over stuff like M80 power supply on and off, M220 and 21 speed and extrude factor overrides. Basically it gives you an overview of every single command that you can send to Marlin to make it do whatever you want. And these commands will allow you to configure a huge part of your firmware without having to edit it in the configuration, then compile and re-upload it to your board. So you can basically just send it the G-code and then store it in EEPROM, and it will automatically load it the next time you power up your printer. So for the next file, I'm going to be heading back to Configuration.h. You've seen the most important settings of that already. So this time around, I'm just going to go through Configuration.h again and show you all the settings that are somewhat relevant that I've used before, and basically show you what they do and how you'd use them. Right up here you can set your custom name for the firmware, so you can input, for example, a name, Tom, and this is my firmware for the Big 90, and that way you can tell which firmware is running on your printer at any time. Moving down past the mainboard selection settings, you can tell your firmware how many extruders it uses. The default is 1, of course, but Marlin supports up to 3 independent extruders. So if you input 3 here, that basically tells Marlin that you have a triple extruder setup. Next setting down here is the power supply setting, and that tells Marlin how it should switch on and off your power supply if you are connecting the power supply online to your mainboard. On an ATX supply, that is the green line from the big ATX connector, and for example on the RAMs, the PS on connector is right next to the reset button. So on my printer I have that one wire connected, and that allows me to turn on and off the entire power supply with a M80 and M81 command, which is really nice because it saves some power and allows you to turn off the printer in a safe way, for example through Octoprint and just making sure that nothing can go wrong, because all the high power components aren't going to be receiving 12 volts anymore. You can define if the power supply should be turned off when you turn on your printer the first time. So if you uncomment this section, you will need to send an M80 before you can do any moves or printing or heating up, before you can do anything with your printer as you turn it on. Moving on to the advanced thermistor settings. The section that's of interest here is the temp residency time and temp hysteresis. Basically what this does is when your slicer inserts a M109, so basically it tells the printer to heat up its hot end and wait for it to reach that temperature. Now what Marlin does is it waits for the temperature to stay within plus minus 3 degrees Celsius for 10 seconds. So if you have a hot end that isn't very good at keeping its temperature and overshoots or oscillates around, you can get it to print by increasing the hysteresis window to something like 10 degrees Celsius, but that's more of a dirty hack. And you should instead run a PID auto tune and get your hot end stable. So these are some settings that you can mess around, but usually you shouldn't have to. In the next section you can set the sane minimum temperatures, and that's a safety feature. So if the connection to one of your thermistors breaks, Marlin can detect that and say, hey, something is wrong there, you should probably go fix it. However, if you're printing in a very cold environment, like in the winter in your basement, the hot end and heater bed might have below 5 degrees Celsius. So you can decrease that to say 2 degrees Celsius, and you're still going to get the full safety features from that. On the other end of the spectrum is the max temp. That protects your hot end from melting down. The default here is 275 degrees Celsius, which is a tiny bit too hot for a Teflon based hot end. When setting this setting, keep in mind that you will have some overshoot as the hot end heats up. So if you're printing at 240 degrees Celsius, don't set it to 241, because that will trigger each time your hot end heats up. Set it to a safe limit for your hot end. If you're using something like an E3D hot end, the safe temperature for that is 300 degrees Celsius before the thermistor starts to lose its accuracy. So actually the max temp for that would be around 350. However, if you're using a Teflon based hot end, set that to about 255. For the heated bed, you should set it to a temperature that your bed can realistically not achieve. So if you're using a Prusa PCB heater, that can realistically not achieve 130 degrees Celsius. So if the firmware ever reports a higher temperature than that, it knows something is wrong. Moving on, there are two more settings that allow you to limit the amount of power sent to your heated bed and to your hot end. Up here is the cycle divider for the heated bed. So for example, if you're using a 12 volt heated bed on a 24 volt system, you should set that to about 4. So uncomment that, and it will give you the same heating power as if you use that same heated bed in a 12 volt system. However, again, that is more of a dirty hack, and you should preferably use heaters that are made for your particular system. You have the same setting here for the hot end, where you can choose the maximum output power. 255 is full power. So if you want to use, again, a 12 volt heater on a 24 volt system, set that to 64 or 63. And it will give the same power output as if you used it in a 12 volt system. Again, it's more of a dirty hack. We already talked about the PID settings on the first video for both the hot end and the heated bed, so I'm going to skip that. And again, you can set the maximum bed power down here, and that stacks on top of the divider setting a bit further up. Now down here there is another safety feature that protects your hot end from burning down at another level than the one that we set in Configuration.h in the first video, and that is the runaway protection. And while the heating sanity check protects the heat up phase of your printer. The runaway protection protects the phase where the heater is already at temperature and where it basically expects it to stay at that temperature. So again, to enable that, remove the comments before that for the extruder and for the heated bed. And you know, safety features is always something that's good to have. Moving on to the mechanical settings, the first one in here is the end stop pull-ups, and you can usually leave the pull-ups enabled. There are some configurations like with an auto bed tramming inductive probe where you should disable them, but generally leave them enabled. The next relevant setting in here is the software end stop setting for both the minimum and maximum positions. Basically, if you leave these enabled, the printer will stop if it thinks that it's going outside of its build envelope at the moment. This is somewhat helpful to protect your printer from harming itself and running into the opposite side of an end stop on an axis. But it won't stop the printer from moving outside of its build envelope if, for example, it's skipping steps or if it doesn't know at which position it is because you just turned it on and haven't homed it yet. So you can leave these enabled, but again, for certain configurations, like for setting up the auto tramming sensor, you will need to disable these. The next section in here is about bed auto leveling or bed auto tramming, tilt, compensation, whatever you want to call it. I made an entire video about that, so you can watch that right here. And the same for the speed, acceleration, and jerk settings. I made an entire video about that just to give you a rough guide of which settings you should use in here, and you can watch that right here. So one interesting setting down here is the EEPROM setting. This allows you to use the M500, M501, and M502 commands to store settings in your EEPROM that you've set via the G-codes that I showed you earlier, instead of having to write it to the configuration. To enable the 500 and so on commands, uncomment the line define EEPROM settings, which will allow you to use the EEPROM. However, you should keep in mind that the EEPROM settings always have priority over the settings that you're setting, for example, here in Configuration.h. So if you're using the M500 command to store settings in EEPROM, the next time you will upload a new firmware with a changed configuration, the firmware will still load those old values from the EEPROM. So to update that EEPROM configuration, you'll first have to send it an M502, which overrides the settings that it loaded from the EEPROM with the settings that are stored in the configuration, and you'll then have to store those parameters you just loaded from the factory defaults in EEPROM with the M500 command, and you'll have to do that every time you upload a different firmware. And of course that means that you'll be losing the settings that you only wrote to EEPROM, so keep those settings in mind and integrate them into your configuration the next time you decide to update your firmware. Also, you should keep this line here turned on. This will make the M501 command report those settings that you've set to EEPROM to the command line. The next setting is about LCD and SD support. Like with the auto bed tramming probe, I made an entire video about the LCD support in here, for which I used the Wrap It Up Discount Full Graphics Smart Controller, and you can watch that video right here. And that's basically it in the configuration.h file. So let's move on to the configuration advanced file and go through the couple settings that are in there. So the first interesting setting in here that I haven't showed you yet is the controller fan setting. And this is where the next part about the pins will come into play. If you have a fan that is blowing over your electronics, over your motor drivers and MOSFETs and such, you can define a pin that turns that on and off, to which you can connect a MOSFET, a transistor, anything that drives that fan. And Marlin will then automatically turn on that fan if it's needed. So when your heated bed is heating up, or when you're moving your motors and the stepper drivers are enabled, Marlin will automatically turn that fan on and turn it off when it's not needed anymore. For example, on the ramps, pin 16 is still unused and broken out to an expansion header. So if you just put a pin that isn't used on your mainboard yet in there, Marlin will automatically enable that fan connected to that pin. down at the mechanical settings, the end stop only for homing settings is something that you should disable if possible. What you'd use that setting for is if your end stops trigger during a print due to crosstalk between some of the wires, which would cause your print to shift. And basically this setting ignores the end stops as long as you aren't homing your printer through the G28 command. Now, as we scroll down, there's one more setting that you should know about and that you should keep enabled if it should be ever disabled, and that is slow down. So basically, Marlin has a look ahead feature, which is why the jerk setting works so well in Marlin, but that can only work if it has a buffer for the next couple of moves that it can use to plan ahead. If that buffer should run low, it will automatically slow down your print so that the buffer has a chance of filling up. So leave that setting enabled if possible. Now, one more setting that's really useful if you have an LCD panel connected to your printer is the baby stepping feature. Basically, that allows you to fine-tune especially the Z-axis during your first layer or anytime during a print. So if, for example, you're seeing that a print isn't sticking well to your print bed because the nozzle is too high or too low, you can dynamically in real time adjust the height of your nozzle, or also of X and Y, but I don't know why you'd use that. And to use that feature, you need to uncomment this line right here, and you can then use that through your LCD controller. One really interesting feature that I'm usually using to a certain extent on my printer is the advanced feature. Basically, it tries to compensate for the fact that your G-code commands for an instant response of your hot end, but the hot end cannot do that. It has a certain amount of lag to it. And the advanced feature is a try of compensating that. It does work to a certain extent, but it can get ugly pretty quickly. So what I usually do is I enable it and then set the advanced factor to a fairly low value. Like I said, you don't need much here. If you use too much, your extruder will start skipping steps and things will get really ugly. Just make sure that you're also setting your filament diameter correctly, or at least somewhere in the right ballpark, and that you roughly get your steps per millimeter right. Depending on your extruder, this is going to vary, of course. And that's basically it for the configuration advanced file. Now there's two more configuration files. Well, not so much configuration file in a typical sense, but two files that you should know about if you want to dig into Marlin a bit further. And those are the pins.h and the thermistortables files. Basically what the pins.h file does is that it tells Marlin to which pins of your microcontroller each feature is connected. So for example, if you're moving down to the printer board, it will have definitions for which pin of the microcontroller is connected to the X step pin that connects to your X stepper driver's step input, which connects to the direction input, also to which pin the heaters are connected. And if you want to mess with that and for example use the expansion pins to connect extra hardware like an extra extruder, which is absolutely possible, you can define which pins you connect each feature to. So for example, if you want an additional heater for an additional hot end connected to, I don't know, say pin 42, you set the heater 1 pin to pin 42. You'll also have to set a temperature pin, of course. For example, if that is connected to pin 2, which is an analog input if I'm not mistaken. And you can move through all these pins and customize them to your liking. For example, one feature that I find really useful is the power supply control. So if you have an ATX supply, you can use the green wire to turn on and off the power supply through your firmware. So for example, through Octoprint, you can then power down your complete printer, or at least the high power electronics, with a simple M81 command. Personally, I use that with every print. The start G-code has an M80 in it to turn on the power supply, and the end G-code has an M81 in there to completely turn the printer off after each print so that nothing can go wrong when I'm not there. So if you want to hook up your power supply's enable line, you can define a spare pin for that right here. I don't know if 30 is taken or not, I'm just putting 30 here. Now, the way you're going to find out which pins are still free and which ones you can use is by looking at the schematics of your particular board. Most boards are featured on the RepRap Wiki, including schematics and all the documentation you need for that. For example, for the RAMs, we can look at the aux4 header, which is the long expansion header, and we can see that pin 16, 17, 23, and so on are all broken out on that expansion header for you to use. So for example, if you define a feature as pin 16, it basically hook it up to the first pin on that aux4 connector. Now, not all schematics label these pins with the Arduino labels, because the D and A labels like they're used here are the ones that you are going to put in your pins.h file. For example, for the printer board, this looks a bit different because this uses the internal names that the microcontroller uses internally to address those pins. For example, PD4. And the way you're going to figure out which of these PD0 or PE1 or PC1 labels correlate to which pins of the Arduino mapping, you can look up the pin mapping, which is published on the Arduino site. So for example, for the Atmega 2560, which is used on the RAMs and many of the bigger electronics boards, there will be a picture like this, which you can use to translate the internal names, for example, PF1, to the Arduino pin names. So the pin PF1 would be Arduino pin A1, or for example, PA6 would be pin number 28 in Arduino's lingo. The same type of pin map is available for pretty much any Arduino compatible processor, including the smallest ones. And the last part of Marlin that I want to show you is the thermistortables.h file. This is the file where all the information is stored about the thermistors that you're picking in the configuration. So if you go over to the configuration and pick, for example, the Semitech thermistor number 5, Marlin will then head over to thermistortables.h and look at thermistor table number 5. Let's see where that is. That is here. Thermistor table number 5. And Marlin will then use these lookup tables to calculate which ADC input values correlate to which temperatures. And each of these tables is basically built in the same way, and each line is correlating one ADC value to a temperature. So if you are using a non-standard thermistor and the vendor, for example, gives you a thermistor table to use, this is the place to put it. You can use any of the thermistor tables and replace it with your own. So for example, if you're saying, hey, I'm not using the 100K EPCOS thermistor in my printer, you can simply take this whole piece here and replace it with the thermistor table that you got. Just again, make sure you get the commas right and the brackets. There is no comma after the last value. When you're done editing these files, save them, close out of your editor, and then open up the marlin.ino in Arduino again. And first of all, check that it's still compiling. Check that you didn't mess up anything in the process of editing these. It's also a good idea to occasionally check in Arduino that you haven't corrupted these yet, because it's really easy to miss a semicolon, a comma, or a bracket. That will easily make your Marlin firmware uncompilable and unusable. So, like I said, you might not immediately need every bit of functionality that I just showed you, but I guarantee you it will come in handy at some point, and at that point you will know where to look for it. So as always, thanks for watching. If you're watching this video in the week that I released it, you still have a chance of winning an Alu Hotend. So head over to the Alu Hotend review to find out how you can enter the giveaway. Until then, see you next week.